Hello, thank you for joining us on today's session, Imagery and 3D Mapping for Local Governments on the Rural Edge. The rural edge is a sensitive zone that exists between urbanization and rural environments. As rural landscapes are transformed by development, the result is often irreversible change that can have significant impacts on the quality of life and the environment. During today's session, we have a number of presenters that will show us how imagery and 3D data from modern low-cost sources can provide the most relevant geospatial information for understanding and managing change within the rural edge. Before we get started, I'd like to cover a few administrative points. First, this webinar is being recorded. We will email a link to this recording to everyone that's registered within a week after the webinar is over. Second, everyone has joined this session in listen-only mode. We ask that you please use the chat window to ask your questions. We will try to answer as many questions as possible at the end of this session. If we don't get a chance to answer your question, we'll follow up with you by email afterwards. And finally, we will be asking 3 polling questions throughout this session. These polls will help us better understand your interests and intentions about your use of drones. Now, to introduce today's speakers, my name is Noelle Loughran. I'm a specialist on the industry marketing team, and I'm your host for today's webinar. I'd also like to introduce you to our other presenters. Tom Sweet, he's been with Esri for since 2012. He has 25 years of experience working with GIS at the state and local level and includes 15 years at county COGS within the state of Pennsylvania. In 2012, he joined Esri as the partner manager for imagery content and has recently moved into the lead role for imagery at the state and local level. Kurt Schwope is our imagery industry lead at Esri. With 30 years of experience with remote sensing technologies, he continues to be on the forefront in introducing image processing technology and applications. Kurt will describe the advancements in the Arcgis imagery platform and how to use drones and raster analytics to significantly improve your organization's productivity. We also have Mark, who is a solutions engineer on the imagery team. With 13 years of imaging experience, Mark is heavily involved with imagery and product quality assurance, driving requirements, and developing imagery solution customers. Mark will be demonstrating the rich imagery capabilities of ArcGIS 10.5 and Pro version 10.4. Now, before I pass this off to Tom, I wanted to let all of you know that the imagery team here at Esri will be hosting a Rural Edge Imagery Workshop over 2 days on June 4th through 5th at the Wisconsin State Patrol headquarters in DeForest, Wisconsin. You will need to bring your own device as this is a hands-on session. Software and demo datasets will be provided. We'll be emphasizing imagery workflows, and we will be doing live drone flights. Check your email in the coming weeks for a registration page, as we will be emailing that out to everyone. Now, before we get started, we will ask our first polling question. So how familiar are all of you with using imagery in ArcGIS? Please select one of the following on your screen. We have no real experience. Have you worked with image files? Have worked with image files doing basic image tasks. Have built, managed image services for base maps. Have done some advanced processing like classification. Not done much with ArcGIS, but have used other imagery software. So we will give everyone a couple of seconds to respond. We already have some of those coming in, so thank you so much for participating. We will go ahead and close this and share the responses with all of you now. So it looks like it's a pretty even split between working with image files, doing basic image tasks, and have built managed image services for base maps. So thank you again thank you so much for sharing all that information with us. And I will go ahead and pass this off to Tom now. Thank you.
Thank you, Noelle. There we go. As I said, thank you, Noel, and welcome everybody. I thought it was worthwhile to perhaps reinforce a couple of things that Noel said in the introduction about what we mean when we talk about the rural edge. The rural edge literally is just that. It's the boundary that exists, or a sensitive zone that exists between the rural environments of your area, Wisconsin, and the areas of expanding urbanization and development. The rural edge can vary in size. It can and scale based on location. It can be found in many different places. It can be found on the edge of, expanding metropolitan areas. It can be found in an island where, as maybe perhaps the picture shows, where there is housing developments kind of encroaching into a rural area. If that area was, completely surrounding the housing development, that would be the island that I'm talking about. Common characteristics, as Noel started to say, that we find in the rural edge are that very often these changes that take place are irreversible. It's not something that you can undo. That includes some of the changes that have very long-lasting effects. And it also presents challenges on what some folks might see as a change in their way of life. It also can present significant impacts on the infrastructure that is needed to support the change, as well as the government services that are involved with trying to manage the change. And as you can see in this slide alone, imagery is a great way to visualize that rural edge. Come on, there we go. So as I was indicating, imagery gains additional importance when you recognize that the rural edge boundaries can be found, virtually across the entire state. You can see areas where the rural edge might be in your ports, around your industries, even at your sports complexes, and the many recreational kinds of areas that are offered throughout the state. And finally, you can see where, as housing development takes place, it also can produce significant occurrences of the rural edge. So there are many influencing factors when it comes to the rural edge. We find that they fall into three categories: economics, government, and regulation. It's also important to understand that imagery supports the informed decisions that are required to address the issues that are found in these, typically three influencing drivers. And just as a couple of examples to spark perhaps conversation is imagery can be used to increase the measure or visualize impacts, like measuring the increases or change in impervious surfaces in an area, managing land cover type changes, and even managing air pollution type changes. These are things that can all be visualized and supported by imagery. When we're talking about government, imagery supports virtually everything that governance does. In a generic sense, it supports the visualization of the change, of the issue. It also supports the digital map production for the decision makers, as well as perhaps the mobile field workers, as well as the various public constituencies that may be given access. In terms of regulation and regulatory issues, again, it's an easy and critical tool to support looking at compliance as well as with existing issues, as well as perhaps change detection, with maybe looking at what issues need to be, what regulatory issues need to be changed, as well as engaging the constituent to get their buy-in into the process. So as we start to talk about imagery, it's important, I think, to understand not only that it has a crucial role, but it comes in many forms. It's an essential tool to the process. It can come in any one of many forms. There's 4 listed here, each one with strengths and weaknesses. LiDAR can be used in the airborne platform as well as terrestrial platforms. Aerial imagery, of course, a lot of people are familiar with. Drone imagery is becoming very popular. And then there's the satellites. Each of these have a very strong contributing purpose for imagery capabilities in the rural edge. One of the things that I think also needs to be understood clearly is that modern imagery collection techniques and analytical power are providing increased accuracy. They're providing capabilities that were at one time expensive. Now they are of a lower cost. They're also driving innovation. The advent of things like the 5G network, the increasing powers of computers, all point towards making imagery a more important process and tool to use as we move forward. This particularly is going to be important as oriented imagery starts to come on the scene. Another important aspect of imagery is that it supports telling your story. It's a compelling way to use imagery and tools like story maps to demonstrate to the constituencies that you want to serve, the story that you're trying to tell. It's a force multiplier in the business of governance. There's an age-old adage that a picture's worth 1,000 words, if you will, unless you're one of the folks that prefer the Chinese version, which is older, that a picture is worth 10,000 words, but it's a very compelling story. It's important to recognize that imagery is authoritative. What that means is that it's much, much more than a pretty picture. There's a lot of data locked inside imagery. It's generally published at some kind of known accuracy specification. It generally comes with some kind of metadata, which is data about the data, and that authoritative aspect of imagery allows you to increase or at least ensure the accuracy of the GIS layers that it's used in combination with. So as a result, you can use authoritative imagery to update your GIS in both automated and manual ways. And by that, I mean, with the advent of, again, computing power and additional tools and capabilities, artificial intelligence and machine learning are starting to come into play to do things like computer-assisted feature extraction. It's important to understand that one of the most critical tools or capabilities of imagery is that it is a perfect tool for visualizing and analyzing change detection, particularly when you can conduct this analysis by comparing the same AOI or area of interest over time. The deeper your library of imagery goes in the terms of time, the more powerful the analysis of change detection becomes. And this is important when you're trying to serve both constituencies that are both internal and external. Hello. Another application that I think becomes important to recognize, and these applications become really an extension of your imagination over time, but it supports, putting together the informed decision-making pieces for monitoring and managing your environment, your natural resources. Simply put, this is the land, the soil, the water, the air, the forests, and then as well as the more complex ecosystems that they create. It also allows you to have the ability to determine policy, if you will, on the ecosystems that or economies that depend on and sometimes threaten those very resources. Imagery is also capable of now moving out of the 2 dimensions and into the 3rd dimensions, and sometimes even the 4th dimension. 3D is generally derived from LiDAR and other kinds of inputs, and allows you to produce things like contours, hillshades, slope, aspect, conducting hydrologic analysis, perhaps some flooding types of applications, supporting flooding applications, and solar applications. So, in all, I think it's important to recognize that the world that we live in is a pretty complicated place, and it's full of change. And as the power and abilities start to evolve, it's generating mountains of data. And this is accelerating, very quickly over time. This in itself tends to cause many challenges, but I think, as you'll see later in the presentation, the exploitation and analysis of imagery content is a crucial and empowering thing in your GIS to meet these challenges. And the imagery has been, or has indeed become, a cornerstone of your GIS, whether it's being stored, managed, and distributed in your system of record, whether it's enabling engagement with all of your constituents throughout through Imagery Services, and and also harvesting and then regurgitating the insight that's gained through the analysis. So with that, I will turn it back over to Noel for another polling question.
Thanks, Tom. So here is our next polling question. How much has your organization migrated to ArcGIS Pro? Again, you can select one of the following. Not at all. A few people have tried it, but with a limited commitment. We are moving in that direction, but it's not fully adopted. It's fully adopted, but we're not using it for imagery. It's fully adopted to include using it for imagery. And thank you. We have some of your responses coming in already, so we'll leave this open for just a few more seconds to get a couple more of you to respond. All right. Well, thank you so much for sharing your information with us. And Kurt, it looks like we have about 45% of our attendees who have a few people trying it, but with limited commitment.
Thank you, Noel. It always helps to be able to unmute yourself so you can actually have the audience hear what you're saying. But those poll results are very interesting. It looked like in the first round that we had a number of people that were doing things with imagery, And yet in this go around, there has not been a significant migration over to Pro. So the good news is that if you want to keep working with imagery, then Pro is definitely the way to go because of the very powerful and rich imagery tools that we've been adding to it. So let's go ahead and jump right into that. So maybe I can help you a little bit better understand why we are pushing Pro so much. And it essentially all starts with the platform configuration. We do talk about Pro, but Pro in and of itself, yes, it does have the tools, but it also can take full advantage of some of the other more powerful capabilities inside of the ArcGIS platform, specifically Enterprise Server with Image Server. And so, yes, you can work with Pro, you can work with individual image files, LiDAR, last data sets, but what makes Pro really exceptional is the fact that it's this very rich client that can plug into Image Services, so you can manage all your data outside of on a server and then bring that in and do different exploitation work directly on the fly. It's not required, but it's a very powerful thing. And we'll talk a little bit more about that as we go through the presentation. The thing about this platform itself, though, is that we're focused on 4 particular areas when it comes to the exploitation of imagery. The top one and the most obvious one is visualization. But then, of course, we do know that a number of people want to do more than just look at their images. They want to pull information out of that data, so they want to do some type of analysis. A number of you like to use imagery for base maps, and I suspect that you probably mostly get a lot of your orthos from different contractors that fly and collect it. But if you want to get a drone and add it to your production mode, you got to be able to convert those images into ortho photos so you can add them to your image base maps. So map production becomes a key part of any type of drone program itself. And of course, once you get all this data brought in, you have to manage it in such a way. And our recommendation is the image server in being able to set up image services to feed all these various clients. And so overall, that's our strategy. These are the 5 main components that we talk about when we're talking about imagery. The 4 I talked about plus content. Because at the end of the day, content is everything. If you can't bring data into your system, if you can't bring imagery data in, then it isn't nearly as effective. And I think this is one of the greatest strengths of the ArcGIS imagery platform. It's the fact that we can work with all types of aerial, with drones, with satellite images. We support Landsat and satellites from Digital Globe, and we've been working with AI techniques with Planet Labs. So we work with all these different types of images, from drones on up to satellites. Plus, we're also working with full motion video. So as you fly your drone along and you actually want to collect video, we have ways of bringing that in and using that inside of your GIS. So it's very exciting, all these different modalities that we're able to support. As I mentioned before when I was talking about the image server, image services are kind of the best because as you create your archive of imagery, and if you service enable them, then you can work that not only inside of Pro on your desktop environment, but then you can start using the variety of different apps that we're putting together. We have a new one that we call Excalibur, which is a very thin client web app that does nothing but exploit imagery and allow you to make observations on imagery and build up feature layers. And of course, with Imagery Services, you can add them to story maps, and you can put some analytics in your story maps as well as the visualization capability. So, and we'll be touching upon these in the workshop. We're not going to spend a lot of time teaching you how to set up image services, but we will show you the benefits of being able to take advantage of those image services. And this is just kind of a representation of how these image services work. And I noticed in the polling questions that some of you more advanced users, you have gone through and you've set up mosaic data sets and you understand how that data model for imagery works. Maybe few of you understand that we can also set up similar things with your LAS files, so we can manage your point clouds as well. And the key thing about this is that you can start working with many, many terabytes of data. And ArcGIS knows exactly, if you zoom down into a area of interest, it knows based on parameters that you set the exact pixels that you want to see, from whether it's the most recent layer or the most cloud-free layer. It'll put those pixels right up on your screen and you'll be able to exploit it. And you don't have to worry about tracking thousands of image files as you go through the data. So it's a very powerful model on how we do it. And as I said before, takes advantage of the enterprise server and the image server. But we're not going to dig into that too much today. We will talk about it a little bit more at the workshop itself. So now let's take a closer look at Pro. And the thing about Pro, where we recommend it as an imagery solution, is the fact that it is 100% built around the exploitation of imagery. You know, desktop just didn't have the screen power, the muscle to really work with a lot of raster data quickly and efficiently. With Pro, that's all changed. And one of the best examples, the way I can showcase this, if you look at this image, this is actually a WorldView 3 image of San Francisco. And you'll notice how distorted the high-rise buildings are. They're leaning off to the side. It's really hard to tell what's going on in the imagery. That's because the way the satellite took it, it was very highly oblique. In the old version of desktop, ArcMap, you always used to have to work in map coordinate space. Now with Pro, just with the click of a button, you can switch over to image coordinate space. This is the exact same image, but now it's being displayed by the computer in image coordinate space. But it maintains all its georeferencing behind the scenes. So your vector layers, your feature layers, they all perfectly lay over the top of it, but now you're seeing it the way the satellite took it, so those buildings don't look quite as distorted. And because we have that ability to do that, it means we understand how this sensor collected the image itself. So we have very rich and powerful sensor models. And that opens up the whole world of what we call photogrammetry, the measurement of features off of images. So here you can see we're actually measuring the heights of buildings because we have this 3D understanding of exactly how that sensor took that image. And this just kind of goes to some of the power, the visualization power that we have in Pro now, working with images directly. But of course, we have a whole nother rich set of analytics. In the past versions in ArcMap, you used to have GP tools that could do a whole variety of different image processing functions. But now we have raster functions, image functions. These are dynamic tools that you can use to actually manipulate the image pixels on the fly. So if you want an NDVI, you don't have to start a GP tool, identify the file, say run an NDVI, blah, blah, blah. You just click on add an NDVI, and then the system automatically translates those pixels when they're displayed on a screen into the NDVI. It doesn't create additional files, it just does it on the fly, stores it in memory, and it allows you to visualize the data the way you want to visualize it. Mark, when he gets into his demo, will show how this works, but it's a very powerful way of doing advanced image processing without having to create lots of redundant files and spending all this time setting up kind of advanced processing tools to do that. One of our key customers here on the East Coast, Chesapeake Conservancy, they map the entire Chesapeake Bay watershed just using the USDA NAEP imagery at 1 meter. And, you know, up until this point, the highest resolution they had covering the watershed was 30 meter derived from Landsat. But now using some of the more advanced imagery segmentation tools that Mark's going to talk about, they were able to generate land cover for the entire watershed just using a 4-band imagery from USDA. And it was just a great data set and a great example of the powerful remote sensing tools that we're now getting inside of Pro. So with that, why don't I go ahead and turn it over to Mark, and he can show you how these different tools inside of Pro can be used to do these advanced things. So hold on, Mark, I'm going to switch it over to you right now.
All right, thanks, Kurt.
There you go.
Screen's going to be switching over here pretty soon, and you should be seeing my screen now.
We see it.
All right, thanks. So I'm going to jump right into some of the capabilities within Pro. And so I thought I would start with talking about some popular techniques that we have in Pro for extracting features from imagery. And so one of the traditional and more common techniques that have been around the industry for quite a long time is image classification. And so I have there in parentheses traditional and GeoAI. So traditional, things like supervised and unsupervised classification. This is where we take the image as an input and we classify the Okay, it sounds like my mute was on and off. Not sure how much of that you heard, but
About 30
whatever.
seconds. 30 seconds.
Okay, well, I'll move on. So two techniques, supervised and unsupervised classification, and then that's where we're taking the image as an input, and then we're classifying the objects or the pixels. Another technique that is becoming popular and experimental is extracting information using GeoAI techniques and neural networks. And so we'll talk a little bit about that. Won't have too much time for a demonstration, but we do want to let you know that that is something that we're working on quite a bit at Esri, and we already have some out-of-the-box tools for doing that kind of classification. But what we get from these types of techniques are layers. Land use, land cover is one popular one. For local government, another layer is impervious surfaces. So that's actually what I'll demonstrate here in a sec. But the whole point of this is to be able to run these techniques, extract out the information, and then integrate it with our GIS. So here's an example of a traditional supervised technique. This is actually a newer technique using object-oriented classification. So in this technique, we're classifying objects or sort of clusters of the image as opposed to the individual pixels. And so this slide walks through the whole process, and really the first step is just picking the image that you want to extract information from, performing a segmentation or a clustering technique that groups similar pixels together that share a common color or kind of a common shape. And then once we have that layer, we can start collecting training samples. And these are things or features that we see on the image that represent some sort of class. So these could be things like water, bare earth, vegetation, and other types of impervious surfaces. And then we build a classifier, and we support a variety of techniques. The one that I've got in this slide, support vector machine, and that's great for high resolution imagery. Then we can classify the image, and then we kind of go back and probably have to do this a few times. And at the end, we check the accuracy, and then we get some sort of result. And that's what you're seeing there in magenta, showing impervious surfaces of an area in Kentucky. And so here's a different view of walking through that step. So we've walking through those steps, rather. We've got an image. We create the segmentation or the grouping of similar pixels. And then we get kind of this layer that looks like vectors that highlight these features. And then we can start to segment those out into features that we're more interested in. So here is an example of just pulling out impervious surfaces. But then we can incorporate other types of classification or classes into this. So in this example, we've also classified bare earth, roofs, concrete, water features. This is the thematic raster layer, or what it looks like once it's classified within Pro. We can use that as is, or we can merge different features together. And then here's kind of our final result of impervious surfaces overlaid on top of the image that it was derived from. Okay, so those are some slides, a little bit about the techniques. And let me mention what you need from the software standpoint to be able to do these types of classification techniques. First of all, you need either Arcgis Pro at a minimum 2.1 up to the present release, which is 2.3, or ArcMap 10.3.1 with the Spatial Analyst extension, again, up to the current release of ArcMap, which is 10.7. Within Pro, I guess the main difference between performing this in Pro and ArcMap is Arcgis Pro has a wizard UI that steps through each one of the steps as you kind of walk through this whole process. And the wizard is nice to have, especially if you're new at image classification. It takes you from the very beginning steps, and using the wizard, you can hit the next button, move on to the next step, and it just walks you through that whole process. So the wizard started at Pro 1.3. And you do need either the Spatial Analyst extension or the Image Analyst extension to be able to perform classification. Okay, another advantage of Pro is that the UI is enhanced and it's optimized for working with imagery and working in environments where you may have split screens and you want to utilize all the different real estate of a screen. So here's kind of another example of what's available in Pro. This is the training sample manager. So this is a tool that lets you collect the training samples. So a really nice UI optimized for classification. Here's an example of split screen. So I've got on the left on one monitor 3 different views of the same image or the same area of interest. And then on my right screen, I've got all the tools that I might need to perform classification. So again, just a user interface that's optimized for doing image processing and image analytics. Some of the other tools in the more recent releases are some tools that we have for charting. And this is just an example of being able to do histograms and scatter plots and actually dynamically extracting pixels or information from the scatter plot itself. So here I've got the red band and the near infrared band plotted on the X and Y axis. And then I'm just interactively drawing or creating a box over those pixel ranges. And then that on the fly extracts out those pixels on the map that fall within those ranges. So just an introduction to that. We'll be showing a lot more of this out in Wisconsin when we go through the workshop. Okay, I'm going to finish off with showing a little bit of the wizard itself. And so this is just an example of extracting out building footprints from multispectral imagery. And so here I'm choosing which classification method I want, just hit next, next, next. I'll fast forward a little bit just because we're running a little short on time. And here I'm actually collecting training samples. This is a simple example where I've only have 2 categories, rooftops and then anything else that's not a roof. I'm putting that into its own classification. And so with the training sample manager, we can quickly collect samples here, training samples in a variety of different ways. I'm drawing polygons, clicking the segment, and that sort of optimizes and speeds up the training sample collection process. And then we can just kind of fast forward as we hit next, next, next. Here we're choosing the classifier. And then now it kind of got something that looks like building footprints as a thematic raster. But then we can go through some additional QA, QC steps where we can fine tune the results. And so in this example, you can see I've got my building footprints. And so, by the way, these were only, this was a project we did and we're extracting building footprints over these metal rooftop structures. And so that's why you see some classified, some not. It's never going to be perfect. And so we've also added some additional tools to go back and add some features that it may have missed. And so here I'm just manually drawing over the buildings that it missed. So, okay, I'm going to turn it back over to Kurt.
Sounds good. Thanks, Mark. Hey, that was great. And actually, we're going to turn it over to Noel, who's going to do our final polling question.
Thank you. So, like Kurt just said, this is our final polling question. Does your organization have a plan to use drones? As usual, you have one of the following to pick from. We're not considering using drones. We are interested, but nothing planned yet. Formal planning has started with limited flights. Our drone program is up and operational, but not used. Our drone program is operational and part of our GIS strategy. And we have some of your responses coming in. Thank you. And I will go ahead and close this and share the results with everyone. All right, Kurt.
Thanks, Noelle. That was great. I'm just going to go through and make sure that I'm the presenter and that people can see my screen. Okay, can you see my screen now, Noelle?
Not yet.
Okay, hold on for a second. How about now?
We can see your screen. We see your desktop.
Can you see the polling question slide?
Not yet. No, we do not see that yet.
Some reason my name is not showing up in the list of people I can switch screens to, switch presenters to.
Yeah, unfortunately.
Can you see me on the make presenter list?
I cannot, but what I can do.
I can see, oh, there we go. I can see.
It's showing now?
Sorry, everybody. It says I'm the presenter, but you're saying you cannot see my screen.
Not yet. It says waiting to view Kurt's screen.
Okay, well, maybe I'll make somebody else a presenter and then switch it back. Mark, I'm going to make you the presenter again, and then.
All right, yeah, I can resume with the demonstrations.
Let's see if we can switch it back. Okay, I can. Yeah, why don't you just go ahead with drone to map?
Okay,
if you would.
All right, sounds good.
Sorry about that, everybody.
Yeah, no problem. And so before I jump into drone to map, just kind of wanted to talk a little bit about the GeoAI process and what we're doing there. But similar to the previous demonstration I showed with the GeoAI, we're going through somewhat of a similar process where we have input imagery, we prep that imagery, we collect training samples, and that's what we call data labeling. We're essentially just training the model to extract out what we want it to extract out. And then we feed it into some other models, deep learning neural network models, open source deep learning models that can do some of the training and the classification. And then at that step, it gets sent back to ArcGIS, where we can perform some feature extraction, like the example you're seeing here, where we extracted out road detection from imagery. And so, yeah, we're just kind of finishing up on feature extraction. So let's go ahead and switch gears and talk about drone to map. So drone to map is a standalone drone processing application. It runs on Windows, and it's got one job, and that's to take photos coming off the drone and process both 2D and 3D GIS ready products. You can see those products listed here on the thumbnails. We can create orthomosaics, elevation models, and NDVI products as well. For the 3D products, we can create 3D textured meshes, 3D PDFs, and 3D colorized point clouds. So it's very simple to get started. You hit this create button, give your project a name, and then feed in the photos themselves. So we can simply navigate to the location of the photos in a folder, or we can select the individual photos. And you can see those are listed here with its lat long and then its altitude or the height above ground at which the drone was flying. And then once those are fed in, those photos are then loaded into the map. So you can see here we've got the photos of the drone represented by these blue points. So I can click those, get a view of the photo itself. And we also have a ground control process that's built into this. And so these little red X's are the targets that the surveyor collected on the ground. And then we can import those in, and then we can use these points to tie down the orthomosaics or the end products to its actual location on the surface of the Earth. So this is important for GIS users to ensure that we have accurate data and that it aligns properly with our other GIS content. And so once we've imported those, we simply hit the start button, and that'll begin the process of creating the products. So let's go ahead and show you the end result here. So I'll turn off a few layers. And so here's the orthomosaic once it's complete. I'll go ahead and zoom in and show some of the results here. I also have the digital surface model and the digital terrain model in this example. And so you can see both of those layers here. So that's really it. Once you hit the start button, you've generated your products. You can start working with your data right away in your own GIS application, Pro or ArcMap or any other remote sensing application. We can directly start working with the data in kind of standard format. So in this case, we can see it's the outputs are written out as geotiffs for the 2D, and then LAS files for the point clouds and some of the other 3D content as well. There's some basic tools for doing volumetrics, so we can calculate some volumetrics over some stockpiles, for example. We can click this button. That'll open up this project in Arcgis Pro. And so I've already done that for the sake of the demo here. So here's the same project. What it'll do, it'll take all of your outputs and it'll lay them right in Pro as their own layers here. You can start working with those as well. Here's just kind of an example where I've split the screens. I've got the ortho on the left, the elevation model on the right. I've extracted out the building footprints along with some vegetation as vector files, so we can start working with those in a 3D environment. We can also push these up to Arcgis Online. So I can click this button here, and I can choose the layers that I want uploaded to Arcgis Online, and that'll create the correct tile cache or image server if you're choosing to push these up as image services. And then those will then be accessible in Arcgis Online as layers. Once it's on Arcgis Online, that just opens up a whole nother set of capabilities and tools. So here's just kind of a couple examples here of some web applications that I generated. These are all pre-configured templates, so there was no coding or development necessary. And this one just simply compares two different screens or two different maps, and I thought this was a good use case for comparing the two elevation products on the ortho. And we can do things like basic measurements. So here I'm just taking measurement of the building. Oops. Both area and the parameter. Here's another example. So in this case, we're just performing a swipe or a comparison of two different dates of imagery. And so the image that you're seeing now is the drone image. And then the other image, we're just swiping between the World Imagery Base Map back in 2014. And then finally, being able to do something similar, but in this case, we're looking at the point cloud in 3D on the left, and then that location on the right. And then we can just minimize those back and forth. So if we kind of want to expand the screen or the real estate of maybe just one or the other, so click this button, that'll get rid of it. And then we can do things like basic measurements of the point cloud in 3D. And so here, as I move my cursor around, you can kind of see where that, where my cursor is. It's kind of highlighting those points that, so just giving me instant feedback so I know exactly where I'm at. And so I'll just do a basic measurement from the top of the bridge deck to the ground. And then I can do multiple measurements here. Okay, so I'm going to go back to drone to map. And so what I've shown you really is the 2D process. So I just wanted to quickly show you an example of generating 3D models or 3D structures and models, modeling from drone imagery itself. So here's an example. This is just a small shed out in Yucaipa, California. And we flew the drone at 3 different heights or 3 altitudes above ground. And the purpose of this is to be able to see as much or see all sides of the building structure itself. So I'll turn off a few layers here so we can focus on just the image. And so this is very photorealistic. If we can get good photos of the structure or the object that we're interested in, we can model these very accurately in 3D. And then we could take this content and do more with it, start extracting the actual building itself, integrate that with the GIS. Okay, so that's going to conclude the drone to map demo. I'm going to turn it back over to you, Kurt.
Sounds great, Mark. So let me make sure I can get back to my screen. I think I figured out what the problem was. So hopefully people can see my screen now.
Yeah, we see your slides.
Excellent. So I just wanted to touch a little bit on drone to map before we move on to 3D, and I'll just go a little bit fast. One of the things that that Mark kind of alluded to is the fact that there's different collection strategies for different ways that you want to collect. If your primary purpose is to collect orthos and produce these imagery base maps, then you fly kind of a mowing the grass pattern, if you will, back and forth, nice and even, with very good forward edge overlap and some side-to-side overlap. On the other side of the coin, if you want to build those photorealistic 3D models, then you fly some type of orbital pattern around the target and you collect from different look angles or different heights, if you will. Now, to make this easy for you, we've started to work with some of our partners that have developed actual mission planning software. One of these companies is 3DR, and they make a solution called SiteScan, and they make a derivative of it that works with drone to map directly. What's nice about this flight management software is that it can connect directly up to your ArcGIS Online folder. So if you have feature layer sets or other imagery as part of your ArcGIS Online folder, you can bring those in and use that as a base map to determine how you want to collect, whether it's that orbital pattern or that mowing the grass pattern. And you can set all the various controls for your drone on how to go ahead and collect that imagery for your project area. So these are some advanced tools that work with collection, and that will also be part of our workshop. We're going to show you, how to strategize the best collection method, and then actually collect the imagery and then use it inside a drone to map and build your various 3D products, 2D and 3D products. And then this is just a sample slide that shows you all these different products that you can produce using drones. It's very exciting. This is a low-cost way that any organization, no matter how small, a DJI drone is $1,500 max. You can take that out and start building up these very beautiful imagery layers, both 2D and 3D, that can be used to embellish your GIS. So definitely, if you're thinking about having a drone, try to move forward, because I think it's just a great addition for any GIS organization to have. So now let's quickly talk about 3D, and I know we're running a little bit long on the presentation. I apologize for some of the technical difficulties, but Mark just kind of alluded to the powerful 3D capabilities we have, certainly on the visualization side. we continue to expand our ability to work with point clouds. And I think that's the most exciting thing about the latest releases of ArcGIS Pro. There's a number of new tools to be able to take point clouds that are collected from aerial sources, drones and aircraft, from mobile sources moving along roads or rivers, and just terrestrial sources where you put a laser scanner up and start collecting both the inside or the outside and the inside of buildings. It's really exciting what we're doing with 3D. We've optimized the point cloud storage models itself, being able to work with that. In the past, we had this last data set notion. You don't necessarily have to use a last data set anymore, especially inside of Pro. You can just drag and drop your last files directly into the viewer and start visualizing them and doing analytics against them. But then on the exciting side of the equation, we're able to take all these 3D layers and push them up into the web so we can do thin client exploitation of these point clouds. And it's just fantastic, the visualization things that we can do, as Mark was showing with that railroad bridge. Some GP tools that we've recently added that can improve your work with LiDAR and point clouds. We can now colorize a point cloud. It used to be in the old days, you would kind of show colors with the point clouds based on different elevation settings or maybe even the intensity of the LiDAR. But what we can do now is actually take a RGB image, marry it up with the point cloud, and then all the individual points in the point cloud will take on the RGB or the color values of the image that corresponds to that point cloud. So you can create these photorealistic point clouds, if you will, for visualization purposes. We've also added a number of new statistics that really help out with, doing things like using point clouds to determine impervious surfaces, your green space, your vegetation. If you have any requirements for determining biomass and those types of things, we now have the statistics in there to be able to work with point clouds effectively to do that type of rich analysis of land cover, if you will. As we talked about before, there's a thinning strategy that we have. This is especially important if you ever were to get a mobile LiDAR device, and the prices of these are coming way, way down. So I can actually see a municipality getting a mobile LiDAR capability. But, imagine that that truck stops at a traffic light and it's sitting there collecting millions and millions and millions of points covering at one area. You might need a tool to go in and then logically thin all those points out so you don't have multi-petabyte data sets that you have to work with. So this new thin last capability is designed to do that. And then the tools that Mark is going to show really quickly is just what I'm very excited about and what you guys should be aware of is the ability to classify ground, classify buildings, classify out vegetation, and use point clouds as a feature extraction method from your data set. And of course, the nice thing is that once you do all this extraction, whether it be point clouds, meshes, 3D building models, or objects, you can now put those into this new Index 3D scene layer package. This is an OGC, an open source standard that Esri's developed. We've shared it with OGC, and it allows you to push all these great visualization 3D scenes into the cloud, into the web, so you can share them with your customers just using a thin client exploitation tool. So it's very cool to be able to do things like this. And like I said, thin client visualization, very powerful for everybody to use. So what I'm going to do now is turn it back over to Mark and let him finish up showing off the 3D capabilities of ArcGIS Pro.
Okay, thanks, Kurt. So this will be about 6-7 minutes, so I apologize, we'll be going over the allotted time here, but we'll go ahead and move through this. So what I'm going to demonstrate now are the ability in ArcGIS Pro for classifying point clouds, extracting building footprints from the point cloud, and then bringing those building footprints to life and modeling those in 3D and then pushing those up to the web. So many of us, when we get LiDAR, we kind of get it in this form. This is a raw, unclassified LiDAR data set that you're seeing on the screen. And often what we want to do with this, besides 3D content, is we want to just create derivatives of that, elevation derivatives from that, from the point cloud itself. Here's an example of taking that raw LiDAR, going through the full classification process, and then we have classified LiDAR. And so that's more useful, more valuable to us. We can start extracting information from it. So here is an example of taking that and then pulling out the building footprints from them. Once we have quality LiDAR data and we've kind of QA/QC'd it, we can generate elevation derivatives. So here I'm toggling between the digital surface model and the digital terrain model. So we can get those two types of products. And that's good. We can create a normalized surface model and start calculating heights, building heights. So the tree canopy, like for example, what you're seeing here in this 3D scene, and then also the 3D buildings that we can extract out once we have those height values from the point clouds, LiDAR derived or drone derived. And we have a whole workflow for generating this type of 3D scene. So the way that we do that is we take our LAS files as input. We can work with an individual LAS file that you're seeing here, or we can work with a collection of LAS data. We call that a LAS data set, and that's where we take 2 or more LAS files and we put it into a data set like you're seeing here. So each one of those red squares represents an individual LAS file that we have now as a collection as one layer. And so I'll fast forward past the part where we actually create that. But once we have that LAS data set, we can work at an entire county level or a city-wide area of interest or even statewide. So it's a good data management technique to be able to take these individual LAS files, put them into a LAS data set. And so once we do that, we can start doing classification on it if we want. So in this example, I got an existing footprint layer that I had before I got the LAS files, and now I'm using that as an input to actually classify the extent of the building. So this could be any kind of existing GIS layer you have. You could use the roadway, if you have that as an input to classify the road network, for example. And once we have that, we can start working with the individual classes of points. So here I'm looking at just the points that represent buildings. And then we can kind of model that and view it in 3D. And so we would want to bring it into 3D for a lot of reasons. One is just to visualize it like I'm doing here, but it also gives us another view or kind of insight into the classification of the points. So here's a building irregularly shaped. We also have a dome-shaped building there. So this classification process does really well with classifying these different types of features. Here's the trees that are sitting in between, or sitting on the median in between the two roads that are classified. Here's an example of a bridge deck. You can see that the process is sort of misclassified. It thinks that the edge of that bridge deck is classified as vegetation, but within Pro we have some tools that will manually let us select the points, and then we can classify those. So this is a step that we would want to do towards the end as we refine the classes and refine the points. Okay, so just a couple highlights of classification, both 2D and 3D. And then here's something that looks a little more realistic. And then being able to take that information, once you extract that out, share it with your communities. And so this is using ArcGIS open data to be able to share the building footprints that other partner organizations might be able to utilize. Many of our customers don't have building footprints, and so just wanted to point out a resource. We've actually taken Microsoft's Geo AI building footprint layer, and we've brought that into ArcGIS. So Microsoft has calculated building footprints using some AI techniques for the entire US. So we've taken those, we've put them into ArcGIS Online. So here's LA, just kind of zooming out. So those are available to all of our users that have an ArcGIS Online account. But you can also take that Microsoft layer, and we've provided the instructions on how to do this yourself if you want to go through over your particular county or city or state. And then we have a set of workflows for being able to work with LiDAR data to create your own building footprints. So if you have access to a point cloud, You can use some of the techniques that we've provided. It works in Arcgis Pro as a 5 or 6 step process. I'm just kind of highlighting the geoprocessing tools here as a 5-step process, and you can walk through that. And that's a great technique for being able to extract this kind of information from point clouds.
And we'll be actually going through that process during the workshop that we have in June.
Right. Yep. Exactly. So we'll go through hands-on and teach you guys how to do this yourself. Again, just kind of taking the results, utilizing Arcgis Online pre-configured applications. And so here I'm doing a comparison of the different techniques we have. So the one on the left is working with classified LiDAR data. The one in the middle is extracting out building footprints with unclassified point clouds. And then that one on the right is some buildings that were extracted out from a vendor. So just comparing those. And then once we have that information, utilizing our solutions templates, part of solutions.arcgis.com, to be able to generate the 3D models that you're seeing here on the screen. So putting it all together and working with it, bringing it to life. So I'll go ahead and conclude my demo there. Sorry we went over. I'm going to turn this back over to Kurt and the rest of the team.
Great, thank you, Mark. So we'll just wrap up, and once again, I appreciate everybody sticking through, bumping into your lunch here a little bit as we went a little bit long. But that last example that Mark showed, that was actually a data set we worked for Warrenton, Virginia on our very first Rural Edge workshop, and they didn't have any 3D models for their entire city. So just using some LiDAR that they had gotten from the state, we were able to produce 3D building models for the entire city of Warrenton during the workshop. And so that's some of the things that we hope that you can get out of attending the workshop and being able to start taking advantage of some of these remotely sensed data sources that you might have available. And we can show you how to take advantage of Pro to be able to get that information as part of your GIS system. So once again, these are the dates of the workshop itself, June 4th through 5th at the Wisconsin State Patrol Headquarters Building, Southwest Regional District. Of course, that's in DeForest, Wisconsin. And as Noel said, we're going to be emailing all the attendees of today's webinar a link if you want to sign up for this workshop, and we'd just love to have you. It's bring your own computer, but we'll set up things ahead of time to make sure you have the latest software, you have all the data sets that we're going to need to work with, and we're going to have some drone flyers there. We'll actually collect drone imagery the first day, and then the next day we'll run it through Drone to Map and show you how to make that part of a GIS system. So it should be a very exciting workshop. I know the times we've had it, the attendees have really gotten a lot out of it, and so we're hoping that you'll be willing to attend. So this concludes the formal part of the presentation. Noel, did we have any questions?
We have one question asking whether or not in Mark's presentation or demo that he just did, if he was using last classification with image analyst or 3D analyst.
There you go, Mark.
Yes, so you will need the 3D analyst extension to do the last classification. And I'm sorry, I put the wrong answer into the wrong question. So sorry, I got those mixed up, but yes, a 3D analyst extension to do point cloud classification.
Okay, were there any other questions, Noel?
One more, and again, actually a couple more coming in. We might have to respond to some of these through email, but one last question for Mark. How much ground control is needed for Drone to Map to work?
Yeah, you actually don't need ground control to process the products in Drone to Map. It's just there as, for those of you that are collecting ground control targets and you have access to a high precision GPS unit, it's highly recommended. You'll just get more accurate results. If you don't have ground control points, you can still run it. You'll just be processing it at the accuracy of the GPS on board the drone. So just kind of keep that in mind.
Good. Yeah, and that's a great question. And like I said, the better your ground control, the more accurate your results are going to be. But as Mark says, you don't need it. And you can actually use the imagery base map inside of ArcGIS Online to actually, as part of your ground control. I noticed one more question about, is there any cost for the workshop? The workshop is free. We're trying to get a budget for, being able to serve lunch and refreshments both days of the workshop. If for some reason we're not able to get that budget, then we might ask for contributions so we can just, bring in lunch in so people don't have to travel out and leave the workshop itself. But other than that, there's not going to be any cost associated for the workshop. So hopefully everybody's willing to just come and have a good couple productive days learning how to use imagery. Okay, did I miss any questions? Did we cover them, Noelle?
I think we did. And we have a
Great.
couple more, but we can respond to those through email.
Terrific. Well, thank you everybody for taking time and listening to our presentation today. Apologize for the technical glitches, but hopefully you learned something, and hopefully we will see you in DeForest the first week of June. So thank you very much.